I got a viewer request. For the first part of this problem, Kevin is throwing a brick with a mass of 2.27 kilograms from a height of 12 meters at a velocity of 13 meters per second downwards. What is the velocity upon impact and the kinetic energy? Assume the acceleration of gravity is 9.8 meters per second per second. To solve this problem, we'll be using the position formula and the velocity formula, along with the quadratic formula, and the kinetic energy formula, which are all listed on this slide. So first, let's plug in all of our values into the position final formula of 1/2 acceleration initial times time squared plus velocity initial times time plus initial position. Plugging our values in, we get a final position of 0 meters being equal to negative 4.9. Negative 4.9 because 1/2 times gravity equals 4.9. Times time squared minus 13 meters per second initial velocity times time plus our initial height of 12 meters. Now we can use the quadratic formula that works for solving an unknown value if the equation is in the format of a times x squared plus b times x plus c. Our equation is in that format. Our a is negative 4.9, our b is negative 13, and our c is 12. Our x, or what we're solving for, is the time in this case. Plugging those values in, we get a time of free fall of 0.725 seconds. A few things worth mentioning. I typically always check my work by using the online quadratic formula calculator. Some calculators also have this function built in. Keep in mind that this equation has a plus and minus, so you may need to complete the calculation with adding, then you might have to complete it with subtracting. You can check your work by plugging in the freefall value into the position formulas above. If you end up with an imaginary number or a syntax error, you probably entered in the formula incorrectly. Now we can plug our values into the velocity final formula of acceleration initial times time plus velocity initial. Plugging in our values, we get a velocity of 20.11 meters per second right before the brick hits. Now to get the kinetic energy, we can use the formula kinetic energy equals 1/2 mass times velocity squared, and plug in our values we found. We get 459 joules of kinetic energy this brick has right before it hits. This concludes part 1 of this video. Be sure to subscribe if you want to see part 2. And if I earned it, give this video a like or a share. Let me know how I'm doing in the comments down below, and feel free to submit video requests to my business email or in the comments down below. Thank you for watching.